Analyze the solubility equilibrium equation. The dissolution of solid magnesium hydroxide is represented by the equilibrium process. MgOH. 2 is an equilibrium with Mg to the power 2 plus 2OH to the power negative. The solubility product constant expression for this process is Ksp equals Mg to the power 2 plus OH to the power negative to the power 2 is equal to 1.8 times 10 to the power minus 11. Apply Le Chatelier's principle to solubility. For a solid to become more soluble, the equilibrium must shift in the forward direction to the right, which represents more solid dissolving into its constituent ions. According to Le Chatelier's principle, a system at equilibrium will shift to counteract a disturbance. To force this system to the right, we must either remove one of the product ions, Mg to the power 2 plus, or OH to the power negative, or decrease temperature, since the reaction is exothermic, though temperature is not a variable in the options. Evaluate the chemical effect of decreasing the pH. Decreasing the pH means increasing the concentration of hydronium ions, H to the power plus or H3O to the power plus, in the solution. Hydronium ions react completely and neutralization occurs when they encounter hydroxide ions, OH to the power negative, in solution. H to the power plus OH to the power negative gives H2O. This neutralization reaction removes OH to the power negative ions from the solubility equilibrium. Determine the equilibrium shift. Because the concentration of the product ion OH to the power negative is reduced, the system counteracts this change by shifting to the right to replenish the lost hydroxide. This shift causes more solid MgOH2 to dissolve. Therefore, decreasing the pH increases the solubility of magnesium hydroxide, making option A the correct choice. The correct answer is option A, decreasing the pH.